Once again, good morning, everyone, and thanks to Crystal and Robert for that housekeeping notes. So I'm Sani Chandi from APNIC Secretariat, as well as a member of the program committee for this conference, and also the Master of Ceremonies for this session. Over these 3 days, we would like you to share your experience and join the conversation online and on social media using hashtag APNIC44. I'd like to now welcome our distinguished guest. We have a few distinguished guests here to come up on the stage. I start with Dr. Lin. Dr. Lin, please come up on the stage. Mayor Lin. Thank you. Gaurav. Minister Ho Chen, please. And Paul Wilson. Thank you. Okay, so I would like to welcome, we are now opening this ceremony with the welcome remarks. And first I would like to invite the chairman of the APNIC Executive Council, Gaurav Raj Upadhyaya. Gaurav.
Hello, good morning, ni hao. Distinguished guests, and friends who are here, especially Minister Ho Chen from the Ministry of Transport and Communications. We also have Mr. Lin, Mayor of Taichung City, Dr. Lin, Chairman of TWNIC, and Paul, DG of APNIC, as well as lots of distinguished guests and friends who are here. Thank you for coming. Thank you for the government of Taiwan and the Taichung City for your support in hosting us here. We've already had many days of event here, and apparently from the feedback we've received at the dinner last night, it has been really excellent support from TWNIC as well as the city government here. Thank you very much. We now continue on today. From today, we already had 5 days of workshops. Now we have another 4 days, which will include policy discussion, as well as the APNIC member meeting, which will continue to discuss about APNIC activities and so on and so forth. We also have some other activities. Every year, this time of the year, we have the APNIC ASO-AC elections. So if you are a participant, please participate in the election process. One of the important things with APNIC and all the RIRs is in the last many years, we've had a big focus on the INR transition. Coincidentally, we also had the ASO review completed just recently. So APNIC will be the first RIR that has received the completed ASO review, the second ASO review, and we have a ASO review session tomorrow. I invite all the stakeholders to come to that meeting because we will receive the review and then see, look at the recommendations and see what we can do there. This review was done after 6 years. The previous one was done a while ago. And I think in the changed context of the INR transition, the establishments of PTI, I think, from a EC perspective, I think we, rather than just look at it as an ASO review, we probably can look at it how the relationship between the APNIC, other RIRs, and ICANN plus PTI evolves into the next decade or so. Having said that, of course, we have our own policy discussion. I think we have quite a few policies. Surprised that we still have V4 policies. I thought we'd not have any V4 policies by now. But that's good. But I think we also have some V6 policies. And this morning, just before we came here, we are discussing with our minister here and other officials of Taichung City on IoT and related technologies and manufacturing. And I was told that, Taichung is probably the IoT manufacturing capital of the world, but also definitely the bicycle capital of the world. So having said that, I think interest in IPv6 and IoT is going to be paramount in coming years. And let's continue working on that. And I've been assured that typhoon is pretty normal in Taipei and in Taiwan, so you should not change your tourism plans. And hopefully by Friday, the typhoon has already gone past. Please enjoy the city, enjoy the meeting, enjoy the food, and enjoy the art markets. But let's also pay attention to topics at hand. Anyway, I'd also like to special announcement before I hand over the next to the next speaker. We have a special guest here today who's been with us in the community for a long time. Alice Kirich is soon retiring from her position as the president of PTI. She served the community for a really long time. So a big thank you to Alice. Give her an ovation about this. Thank you very much. Alice has been a keynote speaker at our events in the past, and we look forward to you being around for a longer period of time and still active in the community. Thank you very much. With that, I officially declare the APNIC44 conference open, and I welcome you to join us in the meetings for the next couple of days. Thank you very much.
Thank you, Gaurav. I would now like to invite Minister Ho Chen from the Ministry of Transportation and Communications for his remarks.
Mr. Gaurav, Chairman of Executive Council of APNIC, Mr. Paul Wilson, Director General of APNIC, Dr. Jialong Lin, Mayor of Taichung City, Dr. Long Song Lin, Chairman of TWNIC, distinguished guests, ladies and gentlemen, good morning. After the safety announcement just now about the typhoon, I believe you can feel relaxed now and sit back to join this successful arrangement of APNIC44. It's an honor for me to be invited to attend the APNIC44 conference in Taichung. APNIC holds conferences in different cities in the Asia-Pacific region every year, which allow ICT industry experts to gather and exchange ideas on essential internet issues, as well as facilitate internet development and cooperation among internet communities around the Asia-Pacific region. Along with rapid development of global ICT and digital economy, the internet has become not only an indispensable part of people's daily life, but also a key driving force of innovation and economic development. Therefore, Taiwan should continue accelerating the growth of broadband network and services, promoting IPv6 upgrade, and establishing smart cities like Taichung in order to improve the living standard to its citizens and better enable the possibilities and opportunities for future internet development. Regarding to our fixed broadband development, the MOTC, my minister, aims to promote the high-speed broadband network under the Executive Yuan's National Digital Plan. We call it DigiPlus. Our goal is to provide 90% of Taiwan population with access to high-speed broadband services with speeds of up to 1 gigabit by 2020, and at least 2 gigabit with the same coverage by 2025. In addition, we have developed free Wi-Fi hotspots in Taoyuan International Airport Link. Currently, we also have deployed iTaiwan free Wi-Fi in Taiwan high-speed rail. Upon that completion, both domestic and overseas passengers can enjoy an easy and convenient internet access environment. As for mobile broadband development, after 2 4G spectrum auctions, Taiwan's mobile internet usage rate has grown rapidly, triggered by the prevailing trend of accessing the internet via mobile devices like smartphones. According to the Taiwan Broadband Internet Usage Survey in 2017, published by APNIC here, in July, 80% or approximately 19 million people in Taiwan used the internet. It's the first time that internet users in Taiwan using a mobile network exceeded ADSL users, with a percentage of 39%. In response to the high demand for mobile broadband, our government planned another 4G spectrum auction by end of this year. Also, this year, the MOTC is planning to release a 5G trial frequency band. Our goal is to complete a 5G spectrum released plan by 2019. In response to the exhaustion of IPv4 addresses, the MOTC has established and has carried out an IPv6 upgrade program, which strategically promotes the deployment of IPv6 in public sectors first, thereby driving a relevant development in private sectors. So far, all external internet services of government departments, such as DNS and email, have deployed IPv6 functions. Following the successful upgrade in the public sectors, now we are actively upgrading the key ISPs to promote IPv6 upgrade. Most of them already plan to provide services with IPv6 functions since 2018. Therefore, it is expected that our IPv6 users' availabilities will substantially increase next year and greatly raising our international ranking on IPv6 availability. As we just exchanged our impression of neighborhood before this conference, I believe most of our guests realize that Taichung City, the second largest city in Taiwan, plays a vital role in gathering a variety of industry, like bike industry. So it is the perfect host for APNIC44. Moreover, acting as a technological hub, Taichung City has made impressive strides in promoting the idea of a smart city. For instance, in recent years, Taichung City has initiated a smart city project in the Taichung Gateway District, which incorporates a number of specific areas such as innovative research and development and ecological residence arrangement. In terms of cultural and tourism, Taichung City has rich cultural diversity, beautiful scenery, and authentic Taiwanese cuisine, making it one of the most popular cities for tourism. Last year, actually, Taichung City was even selected by CNN as the most inhabitable city in Taiwan. I trust many people in Taiwan also agree to that, although you maybe envy that. Therefore, besides attending the conference, please do explore and experience the unique charm of this beautiful city. Finally, I would like to express my gratitude to APNIC and TWNIC for accepting Taichung City to host APNIC44. I expect that many constructive discussions and creative ideas will take place that will help the Asia-Pacific region move toward a wonderful future. I wish this conference a great success and every participant a fruitful time here. Enjoy the conference and enjoy Taichung. Thank you all.
Thank you, Minister Ho Chen. May I now invite Mayor Lin of Taichung City Government. Mayor Lin.
Good morning. Welcome to Taichung. As Minister He Chen-Dan just mentioned, the most livable city in Taiwan, also a lovely city full of cultural diversity and economic dynamism. I would like to thank all the organizers for kindly inviting me to this important event and for choosing Taichung as the place for holding the 44th conference by the APNIC, especially Executive Council Chair Gaurep and Director General Paul Wilson, and also my good friends, the Chairman of TWNIC, Li Nong-song. I think Taichung is located in the center of Taiwan, which is just recently assigned by the central government as the capital of precision machinery. And we consider innovation, R&D, as the most important factor for developing this city into a smart city. And as you may know, we have 60 kilometers industrial clusters here in Taichung. And the clusters range from smart machinery, aerospace, photonics, and machine tools. I think even a significant portion of the iPhone are produced in here, Taichung, as the company, Lagen. And also recently, we have the new factory established by TSMC as the largest factory in its company. I think we are devoted to develop Taichung into a smart city. So we choose the Shuinan Airport, which has been transformed into a demonstration zone for smart city, or smart, low carbon, and innovation center of Taichung. And we are looking forward to incorporating hyper technologies into the public transportation of this city to better manage all the coverage of smart machinery, power, transportation, police, fire, and environmental sanitations. Such advanced technologies to up-to-date software and hardware can be expected to make impressive strides improving urban development and thriving smart manufacturing in Taichung. We proactively work together with academia and the public and the private sectors to implement smart machineries as much as possible, with what we call ABC as the center of the IoT industry and smart machine, AI, big data, and cloud technology. We are planning to use a three-step method to make enterprise introduced into digitalization, formulate comprehensive solutions and automations, and develop service models to industrial applications. The measure will not only solidify the base of machinery industry, but also provide comprehensive information management and smart service for enterprise to accelerate productive assembly, artificial intelligence, cloud technologies, big data analysis, and the IoT. We consider the holding of, for the first time, APNIC here in Taichung is very encouraging for my city to take part in the community for developing more advanced technology and rule of the game in this area. On behalf of the Taichung's 2.8 million residents, I sincerely welcome APNIC to Taichung and strongly suggest that you should pay a visit to our beautiful landscape, delicious food, and our kind people to enrich the conference here in Taichung. Once again, I wish a great success, and not just for the APNIC, but also for Taichung and Taiwan's future. Once again, thank you for your listening. Thank you.
Thank you, Mayor Lin. Now I'd like to invite Dr. Lin, the chairman of TWNIC.
Good morning. First, I'd like to thank you and Paul to making this conference happen in Taiwan. Let's give you one round of applause. Thank you so much. Thank you. Mr. He Chen and Mayor Lin. And I forgot my notes, so the only thing I can talk is, this is beautiful, beautiful city, right? Beautiful Taichung, blue sky, and I believe you've been here for a couple of days, and many of them been here more than 20 times. Paul has been here for 20 times in Taiwan, and then I want to share with you what actually can for you to take away from Taiwan. What actually you can take away from Taiwan and then to share with your friend and your family about Taiwan. Three things I want to discuss with you this morning. Take these 3 minutes as an opportunity to share with you. So I want to share with you, here's my summary. The first one is, let me talk about first one. Something you do and you don't talk in Taiwan, right? Anything you should talk in Taiwan, first use the buzzword as much as possible when you talk to anyone in Taiwan, particularly government officer, right, or politician. It's very good to be very communicative and showing you're very intelligent guys. What is the buzzword? Like something like we already talked in the morning, right? What's the buzzword? Like cloud computing, right? Big data, AI, artificial intelligence, right? Smart city, right? This we talk in the morning. So when you talk to someone, you have very beautiful city. No, that's not the way you should talk about it. Something you should talk, you have very smart city. It's not beautiful, it's a smart city. You have very beautiful opera house, magnificent opera house. No, something you should say is, you have very smart opera house. Right? Smart opera house, that's the key word, smart. Secondly, you have very healthy and rich people in Taichung. No, that's not the way you should talk. You should talk, you have so many big data people here in Taichung. Big data is the word, rich, healthy, right? And what about cloud computing? typhoon is coming. Paul Wilson is going to experience the first typhoon in Taiwan. And why are you so good at dealing with typhoon? There are 20 is average in every year, typhoons in Taiwan. Because what? Because we do cloud computing. The more cloud is coming, the more we can do computing. So we're good at doing the cloud computing in Taiwan. Cloud, thunderstorm, hurricane computing is what we're good at. Right. So this is good, right? And why your government is so efficient? Because what? No, you should say, your government is so artificially intelligent. Why? Your government is artificial, and don't forget about intelligent. Right? So that's the word you should say when you're dealing with the people, talking with the people, wherever it's a private or public space, right? Secondly, what is do not talk? You know, color is sensitive in Taiwan. Don't talk about color. What's color? Black and white. You know, in US, if you talk about black and white, you're reticent. Or you're reticent, you cannot talk about you black. I'm not going to hire you because you're black, because you're white. No. But here in Taiwan, we don't talk about black and white. We talk about green and blue. Right? Green and blue. So green and blue are two parties. They're hating each other. So don't talk about color. When you get on a cab, a taxi, when the taxi driver asking you, the sky is so blue. Don't talk about the sky is blue. No, don't, no. Right. Are you Taiwan is so green? No. Never say that. You're Taiwan. Taiwan is so green, although we have so many forests in the country here in Taiwan. So, remember that in taxi, you're gonna throw out of the window, throw out the car. If you talk about, blue and green, just joking, right? And secondly, I would like to talk about our supply chain. I'd like to promote a little bit about the Taiwan supply chain. We talked about this morning. The amazing things about the Taiwan ecosystem is everything could be reached within 2 hours in this ecosystem, everything. If Mayor just talked about, we have, how many of you are holding an iPhone here? Holding your friend, right? So, for every iPhone, we have a large gun precision. It's about 3 miles away from here. They produce the lens, the camera lens, all here in Taiwan. So, how many of you are holding a smartphone other than iPhone? You guys are not iPhone, all right? So, the MediaTek, the world number 3 IC manufacturer, IC design house in the world, they produce IC, occupy 1/3 of the share of the worldwide IC supply, right? So how many of you are holding a phone? No one holding a phone? Oh, come on, right? So TSMC says actually all the IC was manufactured in TSMC. TSMC was the worldwide #1 pure IC manufacturing foundry in the world. And so as ASE. ASE is the IC worldwide #1 IC packaging company in the world. Other than that, if you combine all these components into a company called Foxconn, you guys have a notebook, right? Well, Foxconn is the worldwide #1 notebook producer, manufacturer in worldwide. So everything here in Taiwan can be reached within 2 hours. Of course, you can buy a Giant. Giant have 50-60% of the market share, manufacturing market share for worldwide bike. You can buy a bike with a 50% discount here in Taiwan, and then go riding around this Taiwan to visit all the companies, buying an IC, right? Buying a lens from Largan, an IC from MediaTek, manufacturer in TSMC, and then packaging in ISE, and then produce an iPhone or whatever phone in Foxconn. one-stop shopping in Taiwan. You never done anywhere in the world, only in Taiwan. Right? So, so that's number 2. Number 3, I kind of run down my time. So number 3, I would like to talk about culture, right? I think you've been here for many days. How many of you have been in the Fengjiang night market? Fengjiang night market, right? You guys have to visit Fengjiang, otherwise you've never been in Taichung. Fengjiang night market, you have to go, right? There are more than 1,000 of a store out there. 1,000 shop, you know, the world #1 night market. This is, no. That's not the world #1 night market. So, Fengjiang, you know, what is the most challenging food you have had in Taiwan? Or most disgusting thing you ate in Taiwan, right? Name 3, so you can share with your friend. You have had that. You have had that. What is the #1? Stinky tofu? Anyone ate stinky tofu? No? You challenge yourself, right? Second one, snake soup. Snake, oh no steak. Snake soup. Anyone eat snake soup? Oh, someone else, that's good. You are courageous. You're courageous, you're brave. And don't forget to buy some medicine before you eat it. Number 3, right? I mean, I think this is the most challenging, even for me. 1,000 years egg. That it will make you immoral for the 1,000 years for your life, right? So I think this. If you haven't eaten these 3, you have to take the challenge. I think it's a very, you know, you have to. If you talk to someone who's been in Taiwan, you never ate one of them, nobody believe you in Taiwan. So try it, right? So that's food. And secondly is people, culture, food, and people. People, you know, Taiwan's people are so nice, right? So friendly. They treat you well. In particular, you're a foreigner. You welcome everywhere. Right? I think you already enjoy that. So, as a matter of fact, literally, you actually can travel from north to south of Taiwan with your pocket empty. Can you believe it? With your pocket empty. I believe people will serve you well, right? Will treat you well, right? With your empty pocket. I guarantee you can do it. If you have a problem to do it, give me a call. Give me a call. Just give me a call. I'll forward the call to Mayor and Mr. He Chen. They'll solve the problem for you, right? I think people with the, you know, I think, you know, that's most of people say, most of visitors say, the most beautiful landscape in Taiwan is people. Is people. So I believe you can enjoy it. So, last, please enjoy this beautiful city, smart city. And you can, may you have a very rich, fruitful outcome. No, not rich and fruitful. A big data outcome out of this conference room. Thank you so much. Thank you.
Thank you, Dr. Lin, for sharing those buzzwords. Hope we remember them. And now I invite Paul Wilson, Director General of APNIC, to give his speech. Thank you, Paul.
Thank you, Sunny. Good morning, everyone. I'm always impressed by someone who can give such a fluent speech without any notes. That's not me. Welcome, and thanks again for joining us here in APNIC44 in the city of Taichung, the smart, big data, artificial intelligence city of Taichung. APNIC people, APNIC staff have been here in Taiwan many times, but it's always nice to be back. This is our 5th conference, actually, in Taiwan, but the last one was held 11 years ago, quite a while. That was APNIC22 in Kaohsiung. So we had 157 delegates from 25 member organisations then, but this year we've got over 485 from 233 organisations and from 43 economies. So that's fantastic to see, much bigger, many more people here than there were 11 years ago. So thank you again. I'm always very struck by the warmth of the welcome that we have in Taiwan. I really appreciate the fantastic efforts of the hosts to make this event a success, and in particular I'd like to thank Minister Ho Chen for being with us, the Minister for Transportation and Communications. Also Mr. Chia Lung Lin, the Mayor of Taichung City Government, and Mr. Song Lon Lin, Chairman of TWNIC, who just gave us that wonderful speech. Thanks also to everyone from TWNIC who's done the work on this event. So our friends Ai-Chin Lu and members of her team, Anthony Lee, Ling Chao and Sylvia Wu, thanks very much for all the hard work to make this, to bring this event to you. To all of you here, big data people, all of you, I really hope that you enjoy the program for the next 3 days. The plenary session before lunch, we've got a couple of great keynote speakers. We've got technical sessions this afternoon and tomorrow. Tomorrow afternoon, as Gaurav mentioned, all the fun starts with the policy SIG. This is a really important part of the conference, and it's still running strong. We've got 6 policy proposals to consider here at APNIC44 this time, which is great. Tomorrow we can also learn about new services and developments in the APNIC services section. I'd like to draw your attention also, as Gaurav did, to the ASO review. This is the review that's just been conducted on the Address Supporting Organisation, which is the body that represents the numbering community inside ICANN, and we've got a session about that tomorrow. We've got a cooperation SIG discussing cross-border cyber cooperation issues. We've got 4 packed BOF sessions in the late afternoon today and tomorrow. We've got our member meeting on Thursday. That's reports and discussion about APNIC business, open to everyone here, not just to APNIC members. Last but not least, we've got socials. Those provide you with 2 more great opportunities this week to make friends and new colleagues here at APNIC44. Welcome also to those who are joining APNIC44 remotely. For all of you and for everyone here in the room, you can participate online via the webcasts and Adobe Connect, and you can join in the conversation on social media, as Sunny mentioned, on the hashtag APNIC44. I started this trip to Taiwan a few days ago with a few meetings in Taipei and also attending the Taiwan Internet Governance Forum. So at that meeting I spoke with a good crowd of at least 200 people about the internet ecosystem and about how internet governance works. But to be honest, I'm actually quite happy to be here in the APNIC44 because we're not talking so much about internet governance. Instead, we're actually doing internet governance here in this room. This meeting is all about building capacity for internet development. It's about sharing best, current, latest practices with experts from around the world. It's about making decisions. It's about developing policies that affect all of us ourselves in our use of IP addresses and resources. So that is really important work. It's helping the internet to grow and to develop in the Asia Pacific. It is internet governance, but it's just not talking about internet governance. It's actually internet governance in action and happening here in APNIC44. So I hope let's all reflect on that, because internet governance sometimes sounds just about talk, but it's actually the action, it's the work that we do. So finally, something I heard this week that I haven't heard yet in this opening. It seems that Taichung has got a reputation, and they say that what happens in Taichung stays in Taichung. So I don't know exactly what that means, and I don't know how to say it in Chinese, I'm afraid. I really do hope, though, that what you learn here this week in the next 3 days, you do actually take it back home. It doesn't stay here, because there's a lot of, I hope, valuable experiences and connections that you can pick up here in this conference. That's the main aim of being here. I hope you also have fun, and you can leave some of that behind if you really need to. It depends on what sort of fun you get up to. But I really do hope it's a good week. I thank you all for your effort in attending here, and wish you all, again, a productive and very enjoyable APNIC44. Thank you very much. Thanks.
Thank you, Paul, and request all the distinguished guests to stay on the stage for the gift exchange and the photo opportunity. Can you take the podium, please? Thank you all, and round of applause to our distinguished guest here. And may I request you all to take the seats on the floor, please? Just leave it. Just leave it. Okay, before we go into the keynotes, we have a small performance by the Taiwanese cappella group. I'd like to invite those group to come up on the stage. Just a small performance, and then we go into the keynotes.
山下日求天，公堂两家边，春水依恋，所以难离开。当作梦露天，山谷求欢颜。阿妹有烟霞，你跳那西天。春水。路也无伴手顶的清风对面吹，17、8岁陪出家，当着少年家，孤人表弟面目白，谁甲人子弟？想要问伊行歹势，心内大悲悲。想要拢滚做红丝，伊爱在心内。等待好时阮来采，青春花东开。听见我面有人来，开门甲看卖。愿笑阮戆半代，雨风偏不知。
Thank you very much for that amazing performance. Just a quick photo with the distinguished guest, if I can invite you all up on the stage, quickly a group photograph, and then we move into the keynotes. A lot of cameras here. Thank you very much. We have two keynotes for this morning. The first one is from Cisco, and the other one, second one is from APNIC, our chief scientist. So I'd like to invite Anand Oswal to come on the stage for his keynote about IPv6 campus of the future.
Look at my slides.
Doesn't need it.
Okay. How's everybody doing today? It's great to be here. Thank you for taking time to attend the session today. You know, I come from Cisco. Today, IPv6 is no longer, just a cool piece of technology. It has a lot of business imperatives. I come to Taiwan from California to talk to you about an interesting case study of how we took our campus, our enterprise to V6. And I'm hoping that each and every one of you can walk away with the key blueprint, a roadmap of how you can migrate your campus and your enterprise to V6. Now we have a packed agenda. I'll first talk about a little bit about the business rationale on why we felt we wanted to take the campus to V6. Talk about the roadblocks that led to a successful adoption. How did we make it work? Talk about a case study for Cisco on Cisco and next steps. So let's begin. As we move from an IPv4 environment to an IPv6 environment, like I mentioned earlier, it had a strong business rationale. And we're finding more and more that as the device capabilities increase significantly from V6 perspective, as content enablement is also on the rise, and as operators start moving their networks towards IPv6. This is more important because as we are finding out that V4 allotments are now no longer existing in Asia, in Europe, Latin America, and the Americas. And 9 months from now, we'll have no more V4 allotments in Africa itself. The next thing to consider is that by 2021, we expect 16.5 billion devices, both fixed and mobile devices, which will be IPv6 capable. We expect 93% of every single smartphone to be V6 capable by 2021. There is reports that talk about 50 billion new IoT devices coming online in a couple of years. That's 1 million devices since we started talking here, right, in 1 hour. So as more and more of these devices come online, migrating and using V6 end-to-end is becoming more and more important. And the next business rationale is really around operational simplicity. As you see data centers and enterprises moving from virtual machines towards microservices and container-based architecture, you'll find that, just take Cisco data center as example. Today we have about 40,000 virtual machines, which will translate to about 400,000 containers. You know why it's so critical for us to now move towards V6. The next thing is, managing a dual stack environment is cost, it increases OpEx, it adds complexity. And if you look at a given IPv4 flow today, it has at a minimum 3 to 4 network address translations, which affects user experience. Now, we've already seen operators moving towards V6. We've seen data centers start migrating towards V6. At Cisco, we believe that the campus is really the last frontier of this migration. We had many of our large customers come to us and ask us, what it takes to move towards V6. That's when we decided that we need to move our own building, our own campus, our own enterprise to a pure IPv6 stack. And I share a little bit about how we got the problem statement defined, what steps did we do, and how did we really achieve it. But there were many roadblocks to achieving successful V6 adoption in our enterprise. First and most important is the end user mindset. Especially when you have a building full of engineers, everybody is used to A.B.C.D, the whole V4 that we've been kind of using the last couple of decades in some sense, right? How do you get this mindset to move towards V6? How do you make sure that they have all the right literature, the cookbooks, the workbooks, the migration forums, the war rooms to ensure that we can change that mindset? Next,
we use a lot of applications. Now, when you're used to using certain set of applications in V4, you want these applications to work seamlessly as you migrate the users towards V6. Next, how do you handle websites which support only V4, like bbc.com? You don't have support for V6. And then within any enterprise, you always have islands of V4. In our case, it was our lab infrastructure, which was only V4. And as you can imagine, most of our labs don't have domain names. So you can't even use DNS64 to map from V4 to V6. And then smartphone users. Android doesn't support DSP V6, at least not right now. So how do we ensure that we can overcome all these roadblocks? So I'll walk you through our approach and how we got there. So if you look at the transition, we really looked at it in 3 different dimensions. The IT the transition, the network validation, and the end user preparation. So what was step 1? Examine the access network. What switches we use, what access points are we using, what's our core network, are they using all the right versions of software to ensure that we can support a single stack V6 network. Analyze within the network the traffic patterns. Identify all the primary applications being used by the user in a given building. And we found more than what we identified, but get the initial subset, the 90%, 80% sure shot applications that we know are being used within the enterprise. Step 2. Here what we did is that we created a V6 SSID on the wireless network, and we basically still had a dual stack infrastructure. And for accessing websites which are not V4 capable, we use the NAT64, DNS64 translation. And for the Android users, we use the Slack RDNSS to ensure that we are able to give them V6 access. Next step. Our real goal is really to ensure that we go on a single V6 stack only. But we had certain roadblocks I talked about earlier. For example, accessing lab networks, which were V4 only, but also don't use domain names. So working with Cisco IT, we came across a very innovative solutions where we were able to map a given V4 address domain to a V6 domain name. So if it's 10.1.1.1, we use 10-1-1-1.cisco.com as the V6 address to enable us to then use DNS64, NAT64 to translate that to access the lab network. At this time, we had about 100 users in the building using the V6 SSID, accessing the application that they used to every single day. And now we took away the V4 network. We migrated to a single V6 stack only, because now they're able to access all the websites, use all the applications, and their smartphones, if they were Android, were able to work on the network. It took us about 3 months. This migration didn't happen overnight. And we were able to work through many applications. For example, you have applications like Real VNC, which won't be supported in V6. Migrate those users to tight VNC. We have a plethora of applications that we had to migrate to the right versions of software, like Outlook for Microsoft. But we were able to systematically go across those, upgrade them, and then we created a blueprint. A blueprint that we can now have shared with other people to see what does it take to migrate an enterprise to a single V6 user stack, end to end. And then we created war rooms, because as you can imagine, when you migrate the entire building of many users, you're still going to find a few issues, few applications that we had not thought about, and how do we ensure that we are able to provide them the support so there's less frustration on the users, to ensure that we're able to migrate all the users in the building to V6. And that's what we did. Now, if you go into little details, this is really how the network looked like. This is, talk about the campus access network, which is V6 only, in a given building, which has 500 engineers working. And how do we access the V4 only islands, which are the labs? How do we access the V6 data centers? And how do we access the internet for V4 and V6 both? We use the Bind9 DNS64 server and the ASR 1002 router for NAT64 translation. And all this was working very closely with our IT folks to ensure that we are able to transition all the users in the building, being able to use all the applications that they are used to seamlessly. So what did it look like? 500 plus users. We have 3 floors, 6 different wiring closets, 500 plus switch ports, 120 Wave 2 access points, 40 to 50 different applications, and a 3-month phased approach working with IT to create a template for migration. So this was a huge scale because this was everybody coming into the building every day is V6 only. And we wanted to make sure that they are productive and they're able to get the same experience that they had with V4. And this was very successful. So now we're able to migrate more buildings. We're also able to work with customers who want to have a blueprint how they can migrate. And just look at the range of services for the building users. From applications like the traditional applications we use, which is your Outlook, remote desktop, Google Docs, WebEx, Skype, etc., to collaboration endpoints, WebEx, telepresence endpoints, Spark clients, devices, every single device, whether it's Mac and Windows and iPhone, Android users across the board. And all the enterprise services, Cisco TV, AnyConnect, VPN services, proximity, everything has to be ensured that we were able to migrate all these services, or all these services worked seamlessly for all the users. And all the management configurations were done only using IPv6 because we don't want to have a trace of V4. And all the protocols, NAT64, DNS64, or Slack for the Android users was used. So let's look at it. Let's step back and say, when we started this journey, what kind of motivated us? First was that I talked about earlier, the campus being the last frontier in the migration towards V6. Second also is that many of our leading customers were looking how can they migrate to V6. And they were looking at us at Cisco to see, can you help me on this journey to migrate? And there's no easy way but eating your own dog food. So working with the resources within the company, with our IT folks, we decided that we will migrate an entire building to start with, 500 users, and now we're in the process of migrating additional buildings as we go. And why is this? Because real experience matters. When you're having a dual stack infrastructure, you still have a backup. And what we really wanted to do is that we wanted to put our step forward, leap forward and say that we are going to migrate this building to V6 only. And that's what we did to ensure that we have a single stack across the building. Now, if you look at the journey we had, if you look at July of last year, we had many enterprises deploying dual stack V4 and V6. All the policy and the management configurations was done using V4. And V4 was deployed predominantly across everywhere we are, in the campus. If you fast forward to today, where we are today, we have an entire campus migrated to IPv6 end to end. All our network policy, our management policy is done on V6. We now ensure that we've added a bunch of solution testing for our V6 solution to ensure that we are able to provide the level of automation, the level of testing, and the blueprint that we have created to give to other people that can help them go on this migration. And today we have, V6 is part of everything that we do in terms of delivering the product as well. Every new product we ship has all the right features for V4 and V6. It's not an afterthought. And we have many of our customers reach out to us asking us to help them migrate their enterprise, to help them migrate their campus to V6 single stack. And that process has begun as well. Now, what were the steps that we took to building the IPv6 only campus? First, most important was ascertain the goals of the project. I talked about the fact that we decided to have a given building. We chose the scope of the building, 500 users. We decided, took an inventory of all that is there in the building. How many wiring closets, how many switch ports, what applications. And then we want to make sure that we don't go on the dual stack route. We wanted to make sure that we go on a single stack route because the operational complexity and the quality of experience for the users always suffers with dual stack. And learn from the case studies. We have built this V6 only campus. We have built a template. We hope that many customers, many partners can benefit from the migration guide that we have, how we systematically went step by step. It took us 3 months, about 90 days from the day we started to when we finished migrating every single user in the building to V6 only. And the most important part that at least I realized talking to the team was manage the early adopter anxiety. There'll always be naysayers. There's always going to be people who are going to worry about what happens to my work or my application when I migrate towards a V6 only infrastructure? Am I being the guinea pig? So you want to make sure you have all the support for them to migrate. Because one step for V6 and a large leap for IT readiness. This has tremendous business context in terms of what it takes for us to migrate not only our data center but also our campus to V6. As you can imagine, we're a large enterprise which is spread across many, many countries, and we want to ensure that we lead the path here. So to wrap it up, what I'll say is that there's never really been a better time to migrate your enterprise and your campus to V6. Adopting V6 is now a business imperative. It's not just, like I said, a cool piece of technology that you can now wait to deploy. It's becoming real. It's affecting the CapEx, the OpEx, and the experience of the users. We're leading the charge at Cisco. We have created this blueprint. We've created the first V6 only campus. We want to ensure that this blueprint is shared with others, that each and every one of you can walk away with a blueprint, a path on how you can migrate your V6 network, your enterprise network to V6 only. Thank you.
Any questions, comments for Anand's presentation? Thanks, Anand. Would you like to take one or two, maybe, if anyone approach? If not, thank you very much, Anand. Thank you very much. Now I'd like to invite Jeff Houston, our chief scientist, for re-engineering the DNS, the root DNS.
The wireless world anymore. All right. This is a talk about infrastructure, but it's actually not a talk about addresses, because down at the bottom of the internet, there are two things in the common infrastructure pool. One of them that we're all familiar with is actually IP addresses, and the second one is, of course, names. And while we are not in APNIC a name registry, we are concerned and interested in name infrastructure. And for a long time, we have been supporting the deployment of a number of root server instances in our region as part of an overall effort in trying to harden and strengthen the domain name system. So today, I'm going to explore this a little bit further and talk about a change in direction for us where we're trying to be smart. Rather than just building a bigger wall, let's build a cleverer system. Let's look at the DNS and look at how we can do it just that little bit better. So today I'm going to talk about the DNS, the root server infrastructure, and some work that we've been doing. This you should all know. Names in the DNS have an implicit hierarchy. www.example.com. And that hierarchy actually reflects how you manipulate that name and look it up. So that example, www.example.com, actually references 4 layers of hierarchy. A root zone, that final dot, the .com zone, the example.com zone, and www.example. Because when you perform a lookup in the DNS, you don't just ask, tell me about example.com, because who do you ask? It's a little bit more detailed than that. Because every zone has its own set of servers, and they're only authoritative for that zone. So the root servers can't tell you what www.example.com is. They don't know. But they can tell you that .com is in the root zone, and they can tell you the servers for that. So the root zone itself, there are 13 root server names. We'll talk a little bit about that. There actually aren't just 13 servers. These days we use Anycast constellations, so I don't know the exact number. I'm not even sure anyone does know the exact number, particularly since some of the cloud providers have moved in as well. There are a lot, a hell of a lot, a metric ton or two of them, many thousands of these things. So how does it work? Because if we're going to talk about re-engineering it, maybe we should actually figure out how the DNS actually works. You see, to ask about a name, you have to ask the right server. For example, what's the IP address of www.example.com? You can't just ask any person on the street. No, no, no. You have to ask the name server of example.com. But who's that? So these days what we do is discovery. We've always done it. The DNS is indeed a discovery protocol. And you might think, wow, that's banging the rocks together, but sometimes that's the right thing to do. Every search starts at the root. So if you don't know whom to ask, you say, hey, root server, tell me about example.com. And the root server says, you know, I don't have a clue. Not a blind clue. However, I can help you because I know about a zone called .com. And here are its name servers. Why don't you ask the same question of them? And so you iterate, because computers are good at mindless iteration. You go to the servers of .com and say, hey, I'm looking for www.example.com. Now, the good servers of .com don't know that level of detail, but they do know that example's there. And they come back to you and say, no, not me, nice try, close but no banana. You need to actually go and ask these name servers, they look after example.com. And all of a sudden, there you go, you ask the right server, you get the answer you're looking for. One query? No. 3 queries, because the name is 3 zones long. So think about this for a second. Every query starts with a query to the root. And so the reason why the root servers are so important is that if you can't ask the root, you're in deep, someone's transcribing this, aren't they? You're in deep, stuff. It's not going to work no more. So the roots are really important that way. So you can be bad. You can be really bad. Because if I can attack these root servers and turn them off for you, your DNS won't work. So that's the essence of the most of this attack issue. If I can prevent the root server from answering your queries, you're hosed. No internet, no nothing. Now, that's not quite true because at the same time, computers are good at also remembering things. They cache the answer. So for example, when this resolver looked up for www.example.com, it remembered the name servers for .com. It remembered the name servers for example.com. And if someone else asked the same resolver the same question, and let's focus, a lot of folk ask for www.google.com, you don't go and search from the root down. The local resolver looks in its cache. How convenient, here's the answer. Because once you're told, you remember it for a while. Most resolvers remember most things. So what questions actually go to the root servers? Well, the vast majority are for names that don't exist. Because all the other names are cached. So around 2/3 of all the root zone queries that we see at the root servers are actually questions that generate, no, that is not in the root, whatever you're looking for, it does not exist in the public DNS. So caching changes the picture a little bit. So now if you want to be bad, and I'm sure you will do one day, I know I do, you actually need to get past these caches. And the way you get past the cache is you don't just ask for the same name, that's boring. You ask for names that don't exist. Because if they don't exist, they're not in anyone's cache. If they're not in anyone's cache, they'll go straight up to the root. So as long as you can ask for different non-existent names all the time, all of your queries are going to go to a local root server. And if you can ask enough of these questions, like, ooh, 10 million a second, 100 million a second, all of a sudden you have the recipe for an attack. All of a sudden you have the recipe for what happened on the, 21st of October last year, when 1 terabyte of questions hit the Dyn servers. And when you get that much data, it's not just the servers that die, the wires melt. The entire infrastructure surrounding that melts, because a terabyte is more than anyone can handle. So these attacks are incredibly easy and incredibly effective. So root servers really are a point of common vulnerability. They're highly public, they're an instant attack surface, and they're just a lot of fun to attack. So, you know, if I can prevent a root server from answering your resolver, you've got a problem. You have a problem for everything, because everything starts at the DNS. So that's the goal, and a lot of people have played that game. Here's an ICANN fact sheet from an attack, it was 10 years ago now. But you know, it's quite common. Here's a more recent one, the events of 30th of November 2015. Attacks are constant in the DNS because A, there is so much Linksys, Belkin and other pieces of that S word again, which have open DNS resolvers, BusyBox software and webcams, that mounting DNS attacks is trivial. Mounting massive DNS attacks is trivial. And sending them to the root, well, who else are you going to attack? They're just out there asking for it, aren't they? So how do you defend this? Do we put the best supercomputers we have with the most fiber surrounding these root server platforms? Do we try and harden this? You can't scale. You just cannot build single server platforms at the same pace that the attacks can happen. It's a sort of a scaling problem where the attackers have tens of millions of devices. Even at 1 query per second, they will overwhelm anything we can build. So bigger, better single servers, you are wasting your time and money. More root server letters. Oh my God, this used to be a technical answer. A long, long time ago, I had more hair, there was this idea that you could only use a DNS packet that had no more than 512 bytes in it. And when you asked for the root what its servers were, the maximum number of servers you could pack into the answer of 512 bytes was the magic number 13. Life has moved on. We're no longer worried about that limit, but the answer is now political. We can't figure out what to do with letter 14, even if we wanted to, can't figure out how it works. There's no real issue there that we figure would make any technical difference. So, you know, it's okay. Why do you want to change it? Seems to be the best answer I can see there. So no, more letters aren't really on the agenda, and it wouldn't help the defense, because the attack is overwhelming. Whether it's 2 letters or 13 letters, if I can overwhelm, I win. So today's practice and what APNIC has been helping with. Keep the 13 letters, but keep on putting more and more instances out there in the Anycast cloud. Make the clouds bigger and bigger and bigger and bigger. So 12 out of these 13 letters now operate relatively large server constellations, where all of these servers respond to the same address. Which particular machine you go to depends on routing. So if you're in Taiwan, you might go to a root server here, or somewhere that routing thinks is relatively close to you. Now, routing is a strange beast, and sometimes it may well think that New York is just next door to here in Taiwan. You know, that's routing. Sometimes the answers are surprising. But on the whole, you have to remember it's not performance that we're trying to solve. I'll say it again because it's really important. We're not after a faster route. You only ask the root when you do a cache miss. Fast no's don't matter. It's no. If I take a second to tell you no, or an hour to tell you no, the answer's still no. Go away. You're not going to anything that has a service behind it. So this is not about speed of response. Having a root server under your armpit doesn't make your life instantly better. No, 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 no. What it does is it absorbs the attack from local nasty people. Because if I try in Australia to attack, I don't know, f.rootservers.net, the poor old machine in Brisbane is going to have a really, really bad hair day. But all the other instances won't even notice that I'm trying my hardest to pull it down. So what Anycast does is it tries to localize single point attacks. It's trying to pinpoint the load and push one instance off the deep end, you know, you're dead, but all the rest survive. So the reason for putting root server Anycast instances out there is to defend. It's not to make it better. The DNS works fine with caching. You don't need to worry about more root server instances to make the DNS go faster. It won't help. So as the traffic levels increase, because the amount of junk increases and the amount of attack volume increases, we end up in a strange game. There is a lot of, what's that S word again, out on the internet. Be it webcams, be it open DNS resolvers, being the great and wonderful internet of redundant 20-year-old software built to the cheapest possible price they can with not a single thought about security. Be aware of the fact that you can't even log into half of the internet, and it was built in the cheapest possible way they can. Those stacks are a mess. The entire internet is toxic. It radiates in the dark. It is that bad. So the attacks simply use these billions of machines and go and attack him. He deserves it today. These are humongously big attacks. A terabyte is more than your wires can take. And we can distribute it across the entire planet. The orchestration of the attack, trivial. The defense, well, what are we doing? We've taken our lesson from the Normans in England in the 12th century, build a bigger castle. Completely unsophisticated. It doesn't try and understand the attack, it just builds a bigger defense space. We put more instances into the Anycast cloud because, hey, we're good at building bigger walls. But it's a really simple defense and it's not very sophisticated. Why? Because the next attack is scaled at the size of your wall. So obviously it's going to be bigger than the wall. Obviously you need to build a bigger wall next time, and so on and so forth. So the other part of this is that the folk who are attacking you are your friends. Because those co-opted devices don't just ask the root servers, they just ask the DNS, which asks your local friendly recursive resolver, which asks the root servers. So at the root level, the folk who are sending you this massively large amount of traffic are the same folk that sent you queries yesterday and will send you queries tomorrow. There is nothing different in the attack other than its volume. This is normal traffic. So we're scaling our root server infrastructure to be resilient against folk who we meant to be servicing by answering questions. This is starting to sound a bit weird because these folk are the ones who are attacking you, your friends. And don't forget that the attack is full of those, well, I'll say it, those shit queries. The queries that don't exist. So what we're building, in effect, by scaling up the root server system, is ever larger sewerage pipes to cope with ever greater quantities of sewerage queries. Does this sound weird to you? Does this sound completely broken? Because what we're building is bigger garbage processors to process the garbage, not to actually, if you will, be what they intended to do to answer real queries. There's something wrong with this. There is something completely wrong with this. It won't scale. It has no future. We can't keep on putting more and more Anycast instances out there and somehow hope that we will get over the attack. The attack will just get bigger. This will fail. So this entire process of the last few years, well-intentioned, is never going to win. We will get overwhelmed. The root will collapse this way. We need to think about this again, and we need to jump out of this cycle. So You know, Taiwan is interesting, not in a good way in some ways, because although there's lots of things happening, the amount of DNSSEC use in Taiwan is 3%. 3% of users validate their queries. That's really, really low, and that's really, really bad, because DNSSEC solves a lot of problems, including believing what you hear in DNS. Because in this case, DNSSEC can help you a lot, because not only can it tell you that the answers you get are genuine and no one's trying to fool you, but it can actually help in defending against attacks. Because if we can push that NX domain answer that the root's busy struggling for, all these queries of nonsense names, if we could get the recursive resolvers to say, no, that's a nonsense name. I don't need to ask the root to know that's nonsense. It's nonsense by definition. We'd be a big winner, wouldn't we? All of a sudden, those 5-10 million recursive resolvers, instead of being your attackers, become your defenders. And you've co-opted an army far, far bigger than your own root server to actually defend the root against attack. So that's a really, really big win, because it would reduce the root server load. That'd be a great thing. We could actually get faster responses to no's if anyone thinks that's a good idea. Hell, no is no. Also, oddly enough, we can also reduce the load on the local caches in those recursives. Triple win. So how do we do it? There are a number of ways out there. The first is RFC 7706. Go to the root, get a copy of the root, run it as if you were authoritative. It's not a bad idea, but I don't know, it just doesn't appeal to me. It seems like a lot of work, and not every root server actually likes to respond to zone transfers. So, nice idea, but I think it's a bit like banging the rocks together. There is another way, and it's beautiful. Came out of folks at JPRS, Kasnawari, I believe, NSEC caching, RFC 8198. Because it takes a very special property of DNSSEC and uses it. When you say this doesn't exist, how do you prove it? How do you sign a name that doesn't exist? Well, that's really, really hard because it doesn't exist. So the approach is you take the two names in alphabetical order, either side of the name that doesn't exist, and sign that. So if I ask for www.example, I get told, no, that's not a real name, and B, every single combination of letters between the word Everbank and exchange doesn't exist. So whether you ask for example 1, example 20 million, or any other combination of letters between those two, you get back the same answer. You get back the same answer. So you can cache it, and you can replay that answer again and again and again. So rather than having those recursive resolvers be your enemies and amplifying attacks, if you cached that NSEC response, you just replay it. Don't forget, the root only has about 1,500 entries in it. There are a very small number of NSEC answers. If you cached them, all of a sudden you wouldn't be asking the root for non-existent names. Existing queries, existing answers, no change to the DNS protocol. We're just using DNSSEC itself to act as a defender for attacks against the root. So rather than trying to build ever bigger roots, and that's not my game, or even with APNIC trying to deploy more and more Anycast instances, maybe if we changed the way resolvers worked, and maybe if they cached NSEC answers, we actually find a way out of this horrible situation we're in. Because if we can make resolvers cache NSEC answers and use them, you can cut the query load at the root by 70%. And you can cut the attacks completely. If every resolver did this, it would be a vastly different DNS. The resolvers also thank you too, because if you actually cached the range, not the non-existent name, their caches actually become a hell of a lot smaller too. Under attack, you actually see the recursive struggling. So the local cache also benefits. Wow, the gift that keeps on giving. So at APNIC, we had a long and hard talk about this through the year. And as this became an RFC, we actually scratched our head and thought, you know, we can take a small amount of the money we currently spend on putting out root server instances, a small amount of money, and talk to ISC and say, can you put this into the next release of Bind, please? And turn it on by default. Because everything in Bind that gets turned on by default never, ever gets turned off. So it is. And in Bind 9.12, you will see this coming out, that it will effectively cache NSEC answers from the root and use the fact the root is signed to do so. So it will actually be doing DNSSEC validation against the root. We're hoping that the other DNS code vendors, NLNet Labs, PowerDNS, and so on and so forth, will also implement this. And you know, it isn't just for the root. If folk actually implemented this for all DNSSEC signed domains, it would be much harder to mount an attack on that domain, because the recursives would do the NSEC caching. The only way you can do an attack is with unique, non-existent names. If you had a signed name, and this was in every resolver, you're a winner too. So we think this is a big thing. We think this is a valuable step towards changing the way we think about DNS and DNSSEC, and actually using it in a way that helps us all get over the rising torrent of the internet of tragically stupid things, and at least put them back into a box that we believe we can handle. Thank you very much. Any questions? Yes. Someone run a microphone over there.
There are microphones. Please state your name before you ask the question and affiliation if you prefer.
I'm Brajesh Jain, an ISP in India. First thing is the letters, root servers. Are they same or different, the letters? And secondary question is, we want instances. For example, in India, if we have 10 instances of letter K, or do we need one instance of each letter?
Do you have a lot of hostile traffic in India? Because the real question about deploying these instances of the root is to try and localize the attack. That's all it is. And if you're saying that where you are is tragically toxic, and it may well be, I don't know, then in our current thinking, that would be the best answer. You're trying to absorb the attacks. That's all you're trying to do. But what we're trying to do is jump out of that and to say, if you actually made the recursive resolvers do DNSSEC and cache NSEC, Reliance turned it on for all of its users and then turned it off again, but that's a different story. If you turn on DNSSEC and do NSEC caching, you don't need lots and lots of root letters, because the problem is solved more effectively by your own recursive resolvers. So this is not a case of more letters or more root server instances. This is a case of the opposite, trying to make those other 10 million DNS resolvers handle the load for you. And surely 10 million is a good answer. Thank you.
My second question was, like you said that bind will take NSEC and bind doesn't change. So what name was in the NSEC could become a real name after some time. So
every single record has a cache lifetime. And the cache lifetime is somewhere between 900 seconds by default, or a longer period if you so choose to use it. So it doesn't mean you store it forever, but you store it for a certain amount of time so that if things do change, you query the root. But instead of querying for every non-existent name, you query once every 5 minutes, once every 10 minutes, once every hour. So yes, we've been there, we've thought about it.
Thanks.
Thank you.
Jeff, I have two questions. I ask the first question first.
Always a good idea.
How you going? Do we have a good methodology to define how many anycasts in a certain area, for example, like Taiwan? Do we have a good methodology? How many anycasts we should have? 1, 2, 3?
Well, I'll answer you the same way I answered the last question. How toxic is the internet in Taiwan? How big is your problem? How many attacks do you experience? Because quite frankly, if the answer is 0, then Anycast instances aren't really solving a problem you need to solve.
But 0 is impossible this day anyway.
We started the internet with 13 individual machines, and it seemed to work just fine.
Okay.
The reason why we put all these root servers out there is not to give you a faster no. Not to give you a faster no. The reason why we put them out there was to make sure you couldn't knock over all of the root servers all at once. Because if you achieved that, knocking over all of the root servers all at once, there is no internet. So this is not a Taiwan problem, or a China problem, or an Australia problem, or a US problem. This is an internet-wide response. And the issue that we've been thinking is, this doesn't scale. The attacks are getting way bigger, way better, and our building of Anycast instances is almost linear. It's not fast enough. How do you get out of that? Get some friends to help. Get an army of recursive resolvers, not to forward their questions to the root, but to keep it to themselves. This seems like a far more sensible answer than anything we've had so far. So let's give it a try.
Okay, the second question is a little bit much interesting. If we look at the IANA table, you see all the registry, GTOD, CCTOD, IP address layer. You actually give the information to the hacker to initiate the attack. Do you think we still need to put those of the, CCTOD, GTOD registries, IP address layer?
Well, the DNS won't work unless you know its address, right? That's the problem. You got a name, you need an address. So whether you put it in a text file at IANA, whether you publish it in the DNS, whether you do both, makes no difference. Nothing works unless you do that, right? It's just the way this stuff operates.
But you
can't make the address a secret if you want it to translate names into addresses, right?
Okay.
Okay, thank you. I think you were next, actually, and then...
Hi, Jeff. This
Hi,
is
Alain.
Alain John from ICANN, Office of the CTO. What you described is a great idea, but somehow assumed that the attack traffic will go through the resolvers. What do you think decide to shoot straight to the root?
All attack and defense is based on the principle that attackers are firstly lazy, and they will do as little as possible for the greatest possible damage. So this is responding to the current wave of attack, where when I co-opt a machine, I simply get it to translate DNS names. Nothing else. I don't need to change resolve.conf. I don't need to change any other behavior. But what if we changed the attack by doing this? And we effectively forced the attack to nominate either a recursive address or an authoritative server for the attack. Interesting question. In some, I think possibly many ISPs these days, it's awfully hard not to use the ISP's own DNS. They take your queries and channel them through their own resolvers anyway. And it's actually quite a challenge to send your own query to far away. So I suspect that we're raising the barrier in a subtly different way, both in terms of the degree of difficulty required in the hack and the challenge required to get your queries out from the local ISP of the machine you've just made into a bot. So I'm not saying it's a perfect answer, but I am saying it kind of breaks the current mold and sort of forces us into and onward in a subtly different way. And I hope it does relieve this issue of just bigger, more root servers, because that's getting us nowhere.
So essentially it works by having the service provider forcing the traffic through their own resolvers.
National content rules, all that kind of stuff. It's really common these days.
Thank you.
Thank you.
Hi, Jeff. Don Sambandarak, journalist now with Disruptive Asia. Actually, I think my question was touched on just then, but how has the response from more repressive regimes which use DNS as a form of censorship been towards solving this problem? I mean, are they not talking, not engaging at all, or is it irrelevant, and are they trying to help? I mean, I'm thinking about the neighbor just across the pond here, but and also my own country of Thailand. But I mean, is it an issue or is it not an issue at all? Thank you.
In some ways, and whether it's a unintended consequence or some other unrelated answer, by corralling DNS queries through those sieves, you make this kind of approach more effective, because it actually forces the queries through the known recursive resolvers that then, if they're doing NSEC caching, would allow you to actually funnel out the attack. So in some ways, oddly enough, that kind of approach is helpful to this. But I'm not saying, let's all go and do that. No, 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 no. I am a great libertarian. Go and choose your own resolvers and use them as you see fit, is my view. But, you know, I am suggesting that those moves are not opposed to this. They actually flow in the same direction. Last question and then lunch.
Yeah, Ajay Kumar from Mumbai Internet Exchange. So my observation is that we have already installed 15 instances in India. Still, when I want to dig, sometime I see traffic of some root servers goes outside. I tried personally to install all root server instances in India. But some operators are saying you have already installed 5 in one location, we cannot support more root servers. How we can handle it?
By stop relying on the root servers as your cause of defense against attacks on the DNS. As I've been saying here, the answer is not more root server instances. You're just trying to build a bigger wall when the attack is 3 miles higher than you. It's never going to work. It doesn't work today. It's not going to work tomorrow. Stop doing it.
Thank you.
Thank you. Okay, I'll turn you over. Thanks a lot.
Thank you, Jeff, for that wonderful talk. I'd like to invite Paul Wilson to give an appreciation to Jeff. Thank you, Paul.
Thanks a lot.
No, that's okay. Okay, that concludes the opening ceremony for this conference. But we do have a lot of technical sessions and plenaries and SIGs as well in the coming 3 days. So we now will split after lunch. We'll have this room and the next door room for two parallel sessions. So I do encourage after lunch, come back and attend whatever interests you. But if you'd like to share your experience of the conference, please use hashtag APNIC44. I hope you enjoy the conference, and if you have any queries, you can identify the APNIC staff with their green tag on the badges, or you can approach our member services lounge and inquire your queries if you have any. The lunch will be served downstairs, 2 levels down, Olympus 2, it's on level 11 from until 2 p.m. And then we resume the sessions in this room as well as the next door. Thank you very much.